everyone. We all grow older, but your projects really have to. We've all, so to start off, I'm Simon Verhoeven. I'm a consultant, and as part of my life, I come in touch with a whole lot of different projects. And sadly, they can't all be greenfield projects. A lot of them are quite a bit more mature and have a certain smell. But now the question, of course, is do those applications have to stay old? Are there ways we can modernize them or bring up to speed? Because yeah, as most of you will be aware, also last week, NIS2 compliance is mandatory for a lot more organizations, which means we have to resolve common vulnerabilities, etc. And that's why I'd like to talk about a tool called OpenRewrite. But first, I have a very easy question. Does this ring familiar for anyone? Is anybody here still using Java 8 or older on their main projects? Or 11? Or is everybody already using 21? Or sorry? Yeah. I had a client 2 years ago that started a new Java 8 project. It was an interesting experience myself. Now, Rewrite itself is a tool that originally started at Netflix. Netflix itself has more than 1,000 microservices, and they had to migrate their logging framework to SLF43. And given the mass scope of their services, you can't just go microservice by microservice. You need to do an automatic, well, ideally, you want to do a perfectly reproducible transformation automatically. You don't want to hire a bunch of interns to go repository by repository. Then Netflix themselves open sourced the project under Apache license 2.0, and it's now under the hood of Modern. Now, what can we actually use the tool for? It actually serves a whole lot of use cases. You can do it for fixes, which can be quite basic things, violations of your company rules, unused imports, there are other errors, or log4shell had a script that we could use to fix the issue rather than having to do it manually. We can do it for migrations from Java 8 to 17, from Quarkus to Spring Boot or the inverse, for Hamcast to SRJ, in case you have a bit of an older version. But we can also do it for a bit more of a complex use case. For example, say you have a repository that's 4 or 5 years old, and it's still using Java 8 and Spring Boot 2.7. Now, a lot of you will likely know that as of Spring Boot 3, the baseline has shifted to 17. Now, in fact, all those different components I mentioned are individual recipes that you can use in conjunction. So there's actually a Spring Boot 3.3 recipe, which will do the Java 8 to 17 or potentially Java 21 migration for you. It will upgrade Spring Security to Spring Security 6. It will upgrade Spring Boot 2.7 to 3.3. It will also do certain upgrades potentially. For example, in case you have a Java 17 runtime, then it won't enable virtual threads. However, if you run the recipe for Java 21, then it will enable virtual threads for Spring. We can also do some utility recipes. For example, there's a cloud suitability recipe to check is actually feasible to migrate this project from an on-premise Tomcat to something in the cloud. Or are there certain vulnerabilities? For example, there's a recipe to check whether you are leaking any keys. Yeah, if there are any questions, feel free to ask at the moment. I'll try to also leave some time at the end but whatever best suits people. Now, how does OpenRewrite itself actually work? So you have your basic text-based search. So this can be a quite simple class. That boils down to an abstract syntax tree of your whole code base. Now, OpenRewrite takes it a step further. A lossless semantic tree is built because we have need of the serialization type, the attributes, and because we also need to preserve the formatting and other metadata. So you can see it can become a very complex given, but when we want to do a full parsing and an application of our visitors and our recipes, we do need a whole lot of information to properly analyze and process this data. Because otherwise the actions we could take would be quite limited. Now, support-wise, OpenRewrite itself has a quite wide ecosystem itself. Behind OpenRewrite, there's a modern team, which have their own clients, and they write a lot of recipes for us. But of course, a lot of contributors such as myself do also provide new recipes. For example, I helped out with the Spring Boot 3.1 migration recipes with some of the Spring Boot, the Java 10 recipes. So there's a whole ecosystem. So nowadays there are even some frameworks that are providing the migration recipes themselves to OpenRewrite to help move developers to the newest version, which is actually quite advantageous for both parties. It reduces the burden on developers to do the migration, but it also helps them out because it reduces the question and support load that they have, and it helps move people away from their older version so they can actually deprecate features more swiftly. So it's a win-win situation for everyone, basically. So our recipe itself, as I mentioned, is just a collection of operations on your lossless semantic tree. They're always fully reproducible. So if I run a recipe today on my code base, or I would run it in 2 weeks, it will always result in the same result. And I can actually compose them, as I mentioned with my Spring example. So recipes themselves, there are 3 different variants nowadays. You can write the recipes yourself. So if it's a bit theoretical, I'll dive into some code samples in a little bit. But I first wanted to lay the foundation for what we're actually going to see. So you can write your own recipe fully yourself, or use a recipe yourself using Java code, which uses visitors. You can make use of refactor, which is now part of Google Error Prone, in which you provide one or more before samples and an after result. These are for more basic recipes, but it allows you to easily compose a recipe. And of course, nowadays you can't avoid AI. But given we want a reproducible scenario, the modern team, they try to start seeing where can we get with OpenAI. At the end of the day, they realized there are still certain limitations, there are hallucinations. So for now, the OpenAI portion for OpenRewrite is more dealt out with more basic use case. For example, are there any errors in our translations to French? Now, as I mentioned, OpenRewrite itself works with visitors. That's the basic component. Visitors basically define what and when should action be taken up in your code base. Your code gets analyzed, you have your inspection, and then you define what should be changed and when should be changed. For example, if I notice this annotation, then something else should be done. Now, above that we have modules. These are used to group different recipes. So if I open the Spring module, you'll see there are a whole slew of Spring models. They can be used to do complete migrations. So, like I mentioned, Spring Boot 2.7 to Spring Boot 3.3. If you've ever done that migration manually, you will note that there are certain interesting challenges, such as Java X to Jakarta. Personally speaking, Spring Security 5 to 6 has some interesting changes and a lot of property changes. If you have to do that manually for 20 projects, you're in for a treat. But yeah, it doesn't have to be for something quite as massive. You can also use it for your testing frameworks. So, for example, here is an example for the Spring Boot 3.3 recipe. As you can see itself, you have your display name itself. It has a brief description, and so this is basically a recipe. You could write it for yourself, but this is just a sample one you can see on their website. So a recipe will always have some text that makes it easily searchable on the website, because Modern itself has a whole catalog, which I'll show in a little bit. So in this case, it's tagged as Spring and Boot. It could also be tagged as Java. You'll see here it makes use of a previous recipe, because this makes use of the Spring Boot 3.2 recipe, which means that the Spring Boot 3.3 recipe will also perform all the steps of an early recipe. So that's one way you can easily compose a recipe and make the whole flow. Then we'll see that atop the Spring Boot 3.2 recipe, there are other new actions, such as the upgrade from 3.2 needs to be to 3.3, of course. The Spring framework itself needs to go to 6.1, etc. So a recipe can be composed of multiple different recipes. So that's where the compositing comes in handy. Of course, if you go to the Modern website, here we can find a whole lot of recipes. So it's not only limited to Java, there's .NET, there are Kale recipes, Groovy, Hybrid, and Java. So if you go to the Java one, for example, there are even struts recipes for those old enough to still be working on those projects. Then we can see the recipes we can make use of. Now, those recipes themselves, there are multiple ways to use these. You can make use of them. There are two main groups of recipes. Those that require configuration from yourself. For example, say you want to rename a package over your whole repository because your company got purchased. For example, like Broadcom purchased certain companies recently. Then you all need to pass in an argument being your old package name and the new package name. But there are all other recipes that don't require any input. So in case there's a certain input that's needed, you'd write a recipe file like I just showcased. Or you could have something quite as simple. This is a recipe I wrote myself. Which is just a very basic recipe to perform the change package that I described earlier. So it has two arguments, my old package name and the new package name. That's all that's needed. Now, the other way, if you don't need any input, then you can just write a recipe yourself, execute it from using either Maven or Gradle, for example. If I just want to do a basic cleanup of my project, I know that in the past not every person left the place quite as clean as needed. There's a recipe to remove unused imports. And then I can just use it from my command line using either Maven or Gradle. However, in this case, the alternative is, if I'm using Maven or Gradle, I can add the rewrite Maven plugin, which has certain dependencies. The dependency list depends on which aspects, which recipes you want to use. That's clearly defined on the website. So in my case, I have certain recipes for Java, Spring, and static analysis. So I add these to the dependency of the plugin. And here you can define which recipes you actually want to apply when you do your Maven rewrite run. Let's see. So for example, if I were to run the common static analysis tool on my codebase, the codebase itself is available on my GitHub repository. The QR code is at a link in case you're interested on testing it out. But this would be the result of the common static analysis. I made some things that shouldn't be done, and it can be applied. So, for example, I had some extra semicolons. There are variables that could be inlined. I made some errors to my Boolean checks, etc.
So it means you modified the POM of your existing project to make the migration or change?
It depends on the recipe itself. So some recipes you can just do from the command line if there are no arguments. In case if it's in your project, yeah, then you would modify your POM, or you could write a second standalone POM to do the setup. But yeah, then you either need the POM itself or a secondary POM, whichever is easiest. Generally speaking, if it's a project I manage myself, I just adapt the existing POM file. Now, so for example, in my case, so let's take a quick look at this project. It's just a very basic Spring Boot 3.2. It is a function, stores that are still using older Java versions or have to return to older Java versions. Likely no. Multi-line text wasn't quite as fun before we had our text box. We shouldn't quite configure our big decimals this way. The way that certain Spring Boot annotations have changed over time. So that's request mapping. Yeah, it's really not done anymore this way. So, yeah.
Does OpenRewrite actually require to know the build system used by the project? Because if it's not Maven and not Cradle but something else?
It doesn't need to know the build system that's being used, but to apply it, you would need to use a build system that's compatible with it. So it depends a bit what you mean. I could either do it from a command line, or I could you build a basic POM file or Kdal file, which would then only contain the OpenRewrite specific dependencies, and to be able to do the Maven run, for example. However, in that case, only your project code would be rewritten, and in case you were then still using Ant or Bazel or something internal, then you would still need to update the dependencies in that pool, of course.
But OpenRewrite itself does not run or is not executed within the context of the application. It's something.
It runs on your code base itself. So I'll show it in a little bit. For example, here in my case, yeah, as you can see, it's just basic Spring Boot 2.7 application with some quirks. It also still uses Hamcast and JUnit 4. So if I go here to my POM file, I have one active recipe. upgrade Spring Boot 3.3. And I do the rewrite run. In this case, it will take a little bit to start, because it's analyzing, it's building up the whole lossless semantic tree from a project. It's scanning it. Potentially, it might have to download some dependencies, but everything should be up to date. And then it will check, of course. And that's the moment the demo goes out.
How powerful is it? For example, can you convert string concatenations into text blocks with variables in it?
I haven't checked the full recipe by myself, but I think it can.
Okay. How about deprecated methods that are being removed from one version of a library to a new version of a library?
Yeah, that's fully supported. Part of the Spring Boot 3.2 actually handles that, because when you switch from Spring Boot 2.7 to 3.3, it's always an incremental step, and that's also why the incremental nature is important, because then you, at a certain point, you'll also have, of course.
It's the demo effect,
Yeah, but I think it's just caching something oddly. But to first answer your question, when you're doing your upgrade, it's always an incremental nature. So that's why when I showed this Spring Boot 3.3 SP, it contains 3.2, etc. Because you can't just, if you go from A to Z, then you might lose some information. But since it's incremental, we know that something got deprecated. Then we know at the moment it gets deprecated, not the moment it gets removed. At that step, we can already do the replacement to the new version. So, for example, in the case of Spring Security, the changes in Spring Security 5 something, certain methods already got deprecated for removal in Spring Security 6. So, as part of that recipe, those methods would be replaced. Yeah,
switch to new switch statement.
Yeah. So otherwise, I'll first continue a bit and then see if I can satisfy the demo codes later. Because that's actually part of my talk. So first of all, an important thing to know. An OpenRewrite recipe, if you want to write something yourself, it's actually very easy to set up. As you can see, in this case, I want to write a Java recipe. And here I just define what's my expectation before I run it, and what should be the transform code. So here we can see the constructor binding isn't needed anymore, and the new format. So analysis-wise, to come back to your question, it will analyze everything in your code base, so the whole semantic tree. Those visitors that I mentioned earlier, they will define what, when, where that needs to be adapted. That can be deprecate methods that you want to replace. That can be just text that you want to replace. It can be your package structure that needs to be adapted. We can analyze using our visitors certain method structures, or even to order that certain methods are invoked, to migrate the invoked functions or the frameworks. Even the classes can be adapted. As long as it can be done in a consistent manner, it's technically feasible. It can be a bit challenging to write at times. I have written some complex recipes, but you can actually do a whole lot. And as we saw in the catalog itself, there's already quite a large catalog. So, for example, right. look at our testing setup, there's an Hamcrest recipe for migrating to ASRC assertions. Here, the page itself, it always lists the recipe list, so you can actually see what's part of the recipe itself. Okay, and this is, as you can see, consists of a whole lot of tiny different recipes. And at the bottom, there's also how you can include or execute it. So either maven-pom, command line, create inscript, or Gradle. And here, if you look at migrate Hamcrest not matcher, you can actually inspect that on GitHub to see what the code looks like. And this is where we see one of those visitors. So we can see what's actually part of it. Yeah, every recipe needs to have a brief description. And then here we have a precondition for the get visitor, so we can define when we need to act. In this case, we're checking whether a method or Hamcrest with a given package structure matches is used. And we're making use of the migration to ASRC visitor. You can write your own visitors. There are predefined visitors. It depends a bit on whether you want to do something from scratch or expanding an existing one. But in this case, you want to migrate the not matchers.
So one more thing. How complicated can this be? For example, can you refactor something that was using reactive into a blocking version that is not using reactive, for example? That would be very complicated, I guess.
It depends on the portions of reactive that you're using. In the sense of a lot of people, for example, use a reactive stack, but are always using it in a blocking manner. That would be easy to replace because it's quite predictable. However, if you're using a reactive stack and you're using it fully reactive, that's something that OpenRewrite itself prefers not to touch too much because the recipe itself should also leave your application in a fully working state. And when you migrate from a reactive to a non-reactive stack, then there are certain concerns that, for example, if you were to move from reactive to virtual threads, then the concern is how would it further cascade, because if you're using reactive, then you might be working with back pressure, and that's a lot less easy to predict. And the whole intent of OpenRewrite is to have a predictable end result that ideally works the same way. So a lot of reactive aspects can be migrated, but
it's more difficult.
Yeah.
Difficult problem in general.
Yeah, indeed. So, and how this actually works? So here we define what we want to check. It uses these methods and the not matchers, and then we have certain patterns that we want to use. So Hamcrest itself has a lot of different versions. Asserted, not, etc. And if it matches, then we will know that we need to act. And then we can define the action that actually needs to happen. In this case, the replacement to the ASRC annotations. And here we can see what actually needs to happen. So here we see the conditions, and here we see what will or may happen. Because at times it might not be needed to act. For example, maybe at import, it might be that you're using assertions or ASRC assertion already in the code base. So maybe the assertions import needs to be added. Certain, dependent on which aspects or which version of Hamcrest you used, maybe we need to remove some imports. So it's a tool that will also clean up after itself. So if you're moving from A to B, all references to A will ideally be removed. And then, as you can see here, I think that's also linking back a bit to your earlier question, is can it actually happen by replacement or moving variables? In this case, within Hamcast, the invocations of your variables is earlier in the calls in your signature in compared to SRC. So all your variables are also kept. Let's see. Let's see if the demo codes are kinder this time. Because I ran it this morning without issues and taking a little bit of time. Yeah, of course, for to activate the recipe. That's the important thing to keep in mind, that I changed a little bit before that. It applied all recipes, but now if there's also an OpenRewrite dependency itself, it will use that one. Also, not all recipes themselves are maybe always quite as useful, or it can be that the recipe itself is quite opinionated. For example, there are recipes to remove guava. There's something to be said for that, in my opinion, nowadays. Guava itself still has its uses, but a lot of people use it because they're not using the new Java functionalities. There are certain recipes in regards to Lombok. Mario Fusco certainly has strong opinions on that front. So now we can see that it defined that there's one recipe trend, Margit Hamkes to SRJ. There's no active style. In general, I advise unless you have a really good use case for it, don't define certain styles for it yourself. Let the tool automatically determine the styles for you. So here we can see that it listed all the steps, all the recipes that were applied. So we can see Hamkes test got impacted, and it got remove ism matcher, asserted boolean to assert j, Hamkes not matcher to assert j, etc. It will not commit anything for you. It's important to keep in mind. So I can just do a git if and will show the changes. If I then go to my Hamkes test, let me see. So my IntelliJ is a bit okay. My IntelliJ is acting up a bit, but normally speaking, it should reflect the changes. Yeah, but normally I have it auto-configured, but okay, time to update IntelliJ. It's always the choice of using an EEP. But yeah, it will fully replace your files, and yeah, it's adapted to the new assert structure that's used. So that's actually quite convenient, because otherwise, yeah, some libraries, when you do the migration, the way that they function invocations are or can change quite a bit. Now, OpenRewrite itself has a very easy philosophy. We do a large migration in small reusable steps. It's idempotent, so it's always be fully reusable, and there's no code leaked to external sources, which can be concerned with certain tools. Is my code being sent offshore? No, it all happens locally on your machine. It's not like tossing your code at OpenAI and asking it, please modernize this code. Now, what does the future bring for the tool itself? Yeah, we're always getting new recipes itself. The support for refactoring itself is being enhanced every time. Support for new languages like Kotlin and Python is being further enhanced, and there are certain CLI integrations in the works. So at the time of writing, there are more than 1,000 recipes on the modern platform, and it has transformed more than 30,000 projects. Now, of course, OpenRewrite itself is only part of the modernization concern. An apple a day keeps a doctor away, so also advise looking into applying extra tools on your code base, so you hopefully don't need OpenRewrite itself. There are tools like Dependabot, Renovate, or Snick that I recommend taking a look at. And there are bases to learn more about it. There's the OpenRewrite documentation. They have their own GitHub page. And they have a very kind and supportive Slack community. Now, first, I mentioned the modern platform. So, OpenRewrite itself is a tool that you can run as a command line, but they also have the modern platform itself, which provides a tool as a service. It's free for open source projects. You can, if you're an organization, please do pay for the tool, which you can, and then you can run the recipes from that tool on your code base. It can be quite convenient if you have larger or more complex recipes. And it provides a bit more insight into what's going on. Now, one interesting thing to also keep in mind is you might have heard Amazon or IBM or Oracle talk about their modernization tooling. A lot of those actually use OpenRewrite under the hood. There's nowadays Amazon Q, IBM Watson X, Broadcom's App Advisor, or the migration toolkit for applications, and by Red Hat. And those are actually kind of wrappers about OpenRewrite for their very specific use case. Well, they have some extra functionality, but the modernization or Rewrite aspect itself applies OpenRewrite itself. Of course, OpenRewrite itself, it doesn't always have to do modernization itself or rewrite something. For example, in my code base itself, I was a bit silly. I put my Amazon access key in there. Everybody might have worked with a junior that was a bit too eager to do their first commit, maybe push some access key to a repository that they shouldn't have. Or you had an old project which contained them. And then it can be quite a challenge to find them, because how are you going to identify access keys in your code base? It's not something you can easily cap for, but these do adhere to certain patterns. And for that, you can write a recipe. For example, there's defined as user secrets. And when I run this recipe on my code base, it will indicate a marker in my code base to indicate, hey, you have an Azure access key here. Please remove it. And ideally, also clean up your commit history to fully erase the presence. Or nowadays, with the new regulations, there's also a recipe to generate your bill of material. So there are also convenience possibilities. Yeah, I wonder, are there any questions?
So is there open source and free version of it and also a paid one? Or
Yeah, OpenRewrite itself is a free-to-use framework under the Apache Commons license too. Then there's Modern itself, that's the platform, which is paid for non-open source organizations. And then, then you do need to pay, but that basically allows a bit more composition of recipes, but you can fully modernize your applications just using the OpenRewrite library.
so it's like an add-on that makes it more
It's
efficient or
it's just an as a service offering. It's a bit more convenience, functionality, quality of life, but you can fully do everything using the framework itself.
It's like Docker desktop as an add-on to Docker, right?
I wouldn't even go so far, to be honest, because Docker desktop actually adds some functionality itself that's not present if you run it locally. I've used it myself at a couple of clients to migrate them from Spring Boot 2.7 to 3.2, and also helped me offload Java X bump because it can be a bit of a challenge.
Are there like maturity levels for these recipes such that I can trust them not to change the semantics during changes or introduce unwanted side effects?
So,
For example, if the recipe itself is wrong,
mm-hmm.
changes the behavior of something it refactors. Is there kind of a maturity level for, or are they peer reviewed? Can I trust?
Oh yeah, yeah. OpenRewrite. Well, there are a couple of different things. OpenRewrite itself is deterministic, so it will always result in the same result. So on that front, it's predictable. It's also why there are those test cases. If I go back here to one of my earlier slides, before you can accept it, you also need to include a test case to verify the expected behavior and it's proper. Now, so in case it's an open source project, so in case an issue is found, either the recipe itself gets temporarily removed or gets swiftly resolved. So in case you do discover an edge case which would unexpectedly change the behavior, which would violate the whole intent and mantra of OpenRewrite, then the recipe would be rectified. Also, given that it's open source, you can freely review the recipes on GitHub yourself, so it can be fully validated by the community. Hope that answers your question. The lossless semantic tree.
Okay, and then the code is generated back in the file format.
Yeah.
And does it preserve everything like comments, spacing,
yeah.
the whole structure of the file that was not touched at least?
Yeah. Yeah, so it only changes what it absolutely needs to changes. And most of the time, unless there's a very good reason, the formatting will also be fully preserved. There are certain markations where it's a bit more complex, but where possible, everything changes. It's very limited in what it touches. You can also do jargon, so even your files are impacted.
Another question, can it be extended to other languages?
Yeah. So there's Kotlin support, Interworks, there's .NET. So people are also working on contributing new languages to the tool. Welcome. if there are any questions, feel free to hit me up. It's a very interesting tool. It can save quite a bit of time. It's also just, for me, I find it fun to work on and contribute to because it exposes me to new frameworks. I try new ones because people ask, can you help me make it too? Or it also exposes me to older frameworks, which can bring me new insights. It's actually the other way around. In the sense of when you run a recipe, there are certain measures that define what will I touch, because the intent is always to have a fairly compiling result. So you'll have X patterns. You might have a recipe that's only measures something very specifically, or you might have something, for example, a very silly example, I know, but developers got very creative in the way that they were getting the first or last element for a collection before we got sequenced collections. You got the 0, first, etc. And then you might have multiple measures for that would be replaced. So ideally speaking, your example, the things it couldn't match, wouldn't be touched. Of course, people are then free to report, hey, I would have liked to have seen this replaced as well on their GitHub repository, and then yourself or somebody from the team or anyone that's interested could expand that recipe to also try to match the use case that couldn't be matched. Now, in case there are certain recipes which will actually insert an error marker, but then that's described in the recipe itself to help you out. Well, it's part, you can run it as like a GitHub action. So you could potentially set up multiple GitHub actions to do that in multiple different steps. And that would be likely be the easiest thing, but I don't quite see why you wouldn't do it fully in one code though, but it's possible.
Because the result you change would be that huge to be
oh yeah.
unreviewable.
Yeah, it's possible. I don't think it's time, but if there are any other questions, or I think I'll need to turn it off. Thank you for your time.